This video is on the objective determine the degrees of freedom for a two-mean hypothesis test. And this is for when the population variances are assumed to be equal. So that pooled scenario, right, where you're going to be calculating that SP, that pooled estimate of the standard deviation. Now, I've already done several videos on these. I've done one video on this objective before, and I've done other videos previously on these pooled scenarios where the population variances or population standard deviations are assumed to be equal. So hopefully you remember me going over this, right? I wrote this out. When you're assuming the population standard deviations are equal, with these populations with unknown standard deviations, so you're eventually going to use the student's t-distribution. You pull samples, and then to estimate sigma 1 and sigma 2, you find this SP, which is this calculation here, right, using S1 and S2 and N1 and N2, the sample sizes and the sample standard deviations. And then eventually you're looking at the difference between the sample means. Right, eventually you're looking at the distribution of x1 bar minus x2 bar. And in this pooled scenario, x1 bar minus x2 bar will have a student's t-distribution with n1 plus n2 minus 2 degrees of freedom. Right, and remember, this is different than the non-pooled scenario, where it was the smaller of n1 minus 1 and n2 minus 1. Here in the pooled scenario, we're working with a t-distribution that has n1 plus n2 minus 2 degrees of freedom, or the sum of the you add the sample sizes and subtract 2. All right, and then then I also wrote up how to calculate the test statistic, which was done in previous videos, when that was actually one of the objectives, finding the test statistic. But we're just doing the degrees of freedom here. Right. So to the question that I'm looking at. Again, if you want to see more about this, what they have to say on it in Newton Alta, just click on More Instruction. Look at their videos, their notes, their examples, read through it, and hopefully that helps you. Okay, so a tutoring company claims that attending their preparatory classes would improve students' performance on a widely used standardized test. One year, a checkbox was added to the test for students to indicate whether they attended preparatory classes. Researchers select a random sample of 1,000 tests. The sample mean score for the 237 students who attended preparatory classes was 592, with sample standard deviation of 152. The sample mean of the 763 students who did not attend preparatory classes was 551, with a sample standard deviation of 164. We're just asked to determine the degrees of freedom for a two-mean hypothesis test for population variances assumed equal, right? Pooled situation, a pooled scenario, to test whether the population mean score of students who attended preparatory classes is greater than the population mean score of students who did not attend the classes. So again, in order to determine the degrees of freedom that we'll be needing, the degrees of freedom for our t-distribution, right, the distribution of x1 bars minus x2 bars, the distribution of the difference of sample means, it's n1 plus n2 minus 2. It's the sum of the sample sizes. Look, now you could take, 237 were in the preparatory classes, that's n1. 763 were not in the preparatory classes, that was n2. Now n1 plus n2 here is 1,000. They told us they took 1,000 tests, and you either checked the box or you didn't. So n1 plus n2, the sum of the sample size is 1,000, but then minus 2, right? Don't forget the minus 2. So the number of degrees of freedom for the student's t-distribution here in this pooled scenario would be 998 degrees of freedom. Right? n1 plus n2 minus 2. Again, pay attention to the answer explanations, please. Read those. Those might help after, especially if you get it wrong. Read through the answer explanations. Maybe you'll do better the next time you see that kind of a question, if you can figure out where you went wrong. And hopefully watching my videos or looking at the more instruction, reading the answer explanations, hopefully all this stuff helps you when you're going through this material on your own. And thank you very much for watching.